Alrighty, let's get started on this lesson. We are going to be graphing the following two functions. So first we are just going to graph this typical quadratic that we should know how to graph, x squared. So we could use our calculator, x squared, then go look at the table. I will do -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Let's go ahead and graph this through -3, 9, 1, 2, 3, and to the left 3, 1, 2, 3, down, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then -2, 4, go to the left 2, go up 4. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. All right, then let's connect these points. And let's put arrows on both sides. And this is the graph of y equals x squared. All right, now let's go graph the square root of x. So the square root and taking the square opposites of each other, let's go look at the square root of x. Let's look at the table. And -1, there's an error. I want to note that. I'm obviously not going to be able to graph that, but I just want to know that for myself. So I have the point 0, 0, 1, 1, 4, 2, and 9, 3. All right, so -1 is an error, okay? Then 0, 0, 1, 1, 4, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 9, 3. All right, I'm going to connect those, and I'm going to put an arrow. And this is the graph of y equals the square root of x. These are called opposites of each other. Why are they opposites of each other? Because the opposite of x squared is taking the square root. Also, I just want to note something before we go forward. The reason why I didn't put an arrow on this side is because anything that uses up negative versions of x is going to be an error. So we would not put an arrow on this side. All right. Also, I want you to note something that's cool on the table. Here we have the point 2, 4, but if you switch that around, you get 4, 2. Then here we have the point 3, 9. When you switch it, we get 9, 3. So that's how we know these are what we call inverses of each other. All right. Let's look at these questions. What is the domain and range of x squared? Okay, so x squared, domain left to right. Well, our leftmost point is an arrow, so that would be -infinity. And our rightmost point is an arrow, so that would also be infinity. We're using up all versions of x. And then the range. Range is how low to high. The lowest point is 0, and that's a point, so I'm going to put a square bracket. And the highest point is an arrow. All right. Now, what is the domain and range of the square root of x? Let's look at it. Well, the range, how much to the left is 0, and how high is infinity. And the range, well, the lowest is also 0, and the highest, we're going to go to infinity. So both the domain and range is 0 to infinity. You start at 0, and you go to all the positive numbers. Now, question C says, why are all the y values for x squared positive? And the reason why is because if you take the square of a positive or negative number, the answer is positive. Think about it. -2 times -2 is +2, or 2 times 2 is still +2. So you will never square a number where you're multiplying it by itself and end up with a negative number. All right, D. Why do all negative x values produce an error for the square root of x? Because you can't square a number and get a negative. So you can't do the opposite, which is the square root. All right. And now, remembering those transformation rules that we learned just a little bit ago, what will the graph of y equals the square root of x minus 3 plus 2 look like? Remember the transformation rules. Well, that minus 3, because it's inside of the symbol, we do the opposite. So that means it's going to make it go to the right 3. And this plus 2 on the outside means it's going to go up 2. Perfect. Alrighty. So now, today, we are going to graph a few different things, but we're really going to focus on graphing square root functions and cubic functions. All right. So notice and wonder, evaluate the square root of x squared. Let's try this in our calculator. That gives us an error. So, why is that? Can you take the square root of a negative number? No, because you will never square a number, positive or negative, and end up with a negative, which means you can't take the square root of a negative. All right. Now let's look at this guided practice. We are just going to graph this function. Let's go ahead and graph this. All right. We are graphing negative 3 square root of x plus 6. All right. Let's just remember some transformation rules here. The negative makes it get reflected. The negative makes it get reflected. The 3, because it's bigger than 1, makes it get narrow. And that plus 6 on the inside makes it go to the left 6. Perfect. All right, let's go look at our table. Negative 7 is an error. I just want to remember that so I don't put my arrow on that side. Negative 6, 0. Negative 5, negative 3. Negative 2, negative 6. I'm not going to bother graphing any of those decimals. 3, negative 9, and the number's going to get too big. There will be an arrow on this side. All right, negative 7, 1, 2, 3, 4, 5, 6. I'm at negative 6, 0. Then negative 5, negative 3. Negative 2, negative 6. And then 3, negative 9. And we can connect them and put an arrow on this side. And make sure you always look at your graph so you make sure that your graph looks similar. Okay. Now, let's look at this next problem. This is an individual practice problem, so I want you to pause the video and try this one on your own. Something very unique about this is that they tell us what numbers we're going to start at. We're going to start at negative 2. On this side, we wouldn't put an arrow anyway because negative 3 says 0. But now we can't even put an arrow if we want to because they told us to start at negative 2 and to end at 7. 7, 3. All right, let's graph this. Negative 2, 0. Negative 1, 1. 2, 2. And 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. All right, we're going to connect them, but we are not going to put arrows on any side because they tell us where to start and stop. And remember, the reason why we use closed circles is because we have a less than or equal to symbol, which means closed circles. And just remember transformation rules. This plus 2 on the inside means that our graph had to start to the left 2, which it did. All right. Now we are going to move on to graphing cubic and cube root functions. Again, opposites of each other. Let's start with this cubic, which is x to the third power. So we will have negative 2, negative 8. Negative 1, negative 1. 0, 0. 1, 1. And 2, 8. Let's go ahead and graph this. -1, 0, 0, 1, 1, and 2, 8. And we could put arrows on both these sides. It's going to end up looking like this kind of like curve thingy. I don't really know what shape you want to call it. And now let's look at how we graph the cube root of x. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. You should see that the points are opposites of each other. They just got flipped. That's because these are inverse functions. -8, -2, -1, 1, -1, -1, 0, 0, 1, 1, and 8, 2. And now we're going to go ahead and graph them. And it's going to look like this sideways curve shape. All right, let's go answer some questions about them. First, starting with what is the domain and range of x to the third? Well, both sides have arrows, which means when you look to the left and the right, it's going to take up all numbers. And up and down, it's also going to take up all numbers. So both the domain and range is all real numbers. Then the cube root of x, both are arrows, which means, again, -infinity to infinity. All real numbers. All right, now the next question says, how are the graphs related to each other? They are inverses. You could say things like the point switch. They're generally the same type of shape, just one's on its side. And now let's think about transformation rules. What does this +2 do? This +2 makes the graph go to the left 2. And then this -5 on the outside makes the graph go down 5. Perfect. All right. Now let's look at this guided practice. Describe how the parent function of f of x is related to the parent function of g of x. Okay. Well, first we need to graph this. And in order to do that, I'm going to make sure to put a table. And they want me to start my table at 5 and end it at 10. Because they gave me what domain to use. Which means I don't put no arrows because I know what I have to use there. Let's look at the table. 5. 5 gives us the point -9.5. Usually we do not graph decimals, but if it is one of the given points, then we have to graph it because it's a part of the range. All right, 5, -9.5. 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.5. 6, 0, 8, 4, 1, 2, 3, 4, and 10, 8. Perfect. And it would have formed more of that curve had we had more space and more numbers to use to graph. 1, 2. Five, 6, 8, 10. Yes. All right. And how are they different? Let's label what each of these things do. The 1/2 is smaller than 1, so that makes it go wider by 1/2. The -8 means it goes to the right 8. And the +4 means it goes up 4. Perfect. And now let's look at the next one. Alrighty. So we are going to first, let me just list the transformations. The -2 on the outside means that our graph is going to go right 2. The -2 on the inside of the parentheses means the right 2, and the 3 on the outside means we go up 3. Now let's make our table. X minus 2 to the third power plus 3. Now let's go ahead and look at the table. We have 0, -5. 1, 2, 2, 3, 3, 4. All right, that's pretty much it. 0, negative 5. 1, 2, 2, 3, and 3, 4. All right, and they did not tell us where to start or stop, so we are going to put arrows here, and that is our graph. So today we learned how to graph 4 different functions. We learned how to graph cubic, which is x to the third, and cube root, which is the cube root with the little 3 there. We are not going to have to graph that one much for the region, so we really want to focus on that cubic. And then also, we have learned how to graph both a square root function and a cube root function. Alrighty, that is all.